In this video, we talk about energy, but before that, we want to review the concept of voltage. So what is voltage? Voltage is the energy or work required to move a unit charge, one charge from, say, point A to point B here. Mathematically, the voltage between A and B equals to the work to be done to move the charge. Then what is the energy? Physically, energy, it is a capacity. It is a capacity to do the work. We use small w to denote the energy. The unit is joule, which is watts multiplied by second. Next, let's look at the mathematically, what's the relationship with energy and voltage. And from this relationship, we want to derive what is energy here. We know the voltage is defined, the work to move a unit charge. So this is a mathematical relationship. So I drop the subscript A and B here for just notation simplification. I'm going to do mathematical justifications. How do we obtain the energy? From this relationship, we will know that dW is equals to V multiplied by dQ. We know, let's recall, what is the current? The current is I omit the time t here. I omit that, equals to dq in dt, right? Current, that's the rate for the charge to flow. Therefore, we have dq equals to I multiplied by dt, right? So we're going to plug dq here. We're going to have dw v I dt. Okay, what is the energy now? We're going to do integral here. So we do integral on both sides here. dw equals to v and I and dt, right? Integral on both sides. So the left side will be w, that's the energy, equals to, this will be on t, right? Because the integral on t. So we can do t naught to t, whatever it is, it doesn't matter. I and dt. This is the energy expression, derive that mathematically. And this is the relationship W equals to here. This is exactly what we have. Voltage, the work, that's the work done to move one charge. And what it is I, that's the charge rate per unit of time. This is a mathematical expression of energy. This is a physical meaning. It should be pointed out that in circuits, some devices supply the energy, some devices absorb the energy. Battery or voltage sources or current sources, they will supply the energy. So when the energy supplies, energy is negative. And some other devices such as resistors, light bulb, they're going to consume the energy. The energy on that device is positive. Next, let's talk about power. So what is the power? Power is the rate of change of the energy. Okay, so basically power equals to dW dt. That's how the energy change with respect to time. Let's review the expression of the energy. So this is the energy. It has integral v multiplied by I, and we do the integral with respect to time. If we take the derivative of the energy with respect to time, that's power. P equals to dW dt. Okay, so I drop t just for notation simplification. Take derivative here. The derivative and this integral cancel out each other. Power t equals to V of t multiplied by I of t here, which is in our next slide, exactly here. In the notation in our textbook, sometimes they drop t bracket here. So they really should be P of t, and this is would be V of t and I of t. But sometimes they drop this t, the argument here for simplification of the notation, to simplify the notation. Otherwise, sometimes it's bulky. If the letter is small case, is lowercase, we know chances are the quantity is a function of time. If we have big P, which is kind of related with the DC, the power does not change with time. The same thing if we have voltage, big V and big I, this is a DC voltage and this is a DC current. Our textbook follow this set of notations loosely, very loosely. So we have to be sometimes be a little careful. The unit of power is watt. Is watt. What's the unit of energy? Energy is watts multiplied by the time. So exactly what we pointed out before. We know this relationship. Power is the product of voltage and the current. We know this relationship probably from physics, from maybe high school.